Okay, now programming so far, our programs are getting more complicated. They're getting longer, there's more going on, okay? In addition to that, we're taking simplified versions of things. We're not doing very complicated things. As the book points out on page 209, our program we've done for calculating pay has been asking for the number of hours worked and what the pay rate is, okay? When in reality, there'd be a whole lot more steps in that. Okay? And the book points out it could be getting the employee's hourly pay rate, the number of hours worked, calculating the gross pay, calculating overtime pay, calculating withholdings for taxes and benefits, calculating the net pay, and then printing the paycheck. So there's a lot going on. We've been glossing over a lot of those problems, okay? So the way we're currently programming, where all this one big program is quickly going to run out of usefulness, okay? We're getting too much together. So what we need to do is split our programs up, okay? We're going to use functions to do that. So with a function, you divide your bigger problem into smaller, more manageable chunks of tasks that you then do sequentially, but you can separate the code, okay? So for example, you could have, this is a picture on page 210, you could have a function that just does part of it. So you have a function that gets the hourly pay rate, that's all it does. Another function that gets the number of hours worked, and another function that calculates the gross pay, and so forth, okay? So by dividing your program up, you reap a bunch of advantages, okay? The first advantage is it's just simpler to code. Okay? You're not trying to create this massive monolithic program. Now, even with the way we're doing things, you've seen me try to approach problems this way. We don't do the whole thing. We get this working, and we get that working. It's called an iterative approach. That's what we do, okay? But with functions, it's even more so. We're even more able to break things into pieces, okay? It also allows for more code reuse. So we can create functions that are more generic. And basically, if you write a function to do something, you never have to write that function again. Take an example of prime numbers. If you write a function to tell whether a number is prime or not, one time, you save it somewhere. Whenever you need to do that again, you just pull out that function. Okay, that's all good things. Okay.
So is a function like how we use like we said the prime numbers, how we determined if that was prime?
Yes.
We use that as a function.
That could be a function, yeah. Basically, a function, we used to call them back in the old days, even before I was programming, subroutines. So it's a small little program that you pull out and make it a standalone. Okay, but it's all within your program, but it's semi-standalone. Okay, we'll see some examples here in a minute. It'll make more sense. Okay. It also allows for better testing. Okay, because you can very accurately figure out, is just this one part of the program working? Okay, and if you test these smaller bits and they're all working, then it's easier to test the whole thing and put it together. Okay. It also makes it quicker to develop. You know, it's quicker to be able to do something small, then do something else small, and do something else small, and do one thing that's big. There's less to keep track of. Okay. And the final advantage is that it makes it easier to work together. Okay, so you have where you can have multiple people on your team working on their own functions. Okay, then you just pull them together and you don't have to share the same code base. Okay, this makes it easier. If you work as a programmer on a team somewhere, you're almost guaranteed to be given a function library that someone's already done that has all the common things that are done. Okay, but then your program is just going to use those. You don't have to recreate the things all over again. Okay. So with functions, there are two basic varieties. There are the void functions and there are the value returning functions. Okay. Both of those functions can take parameters. A parameter is something you send into the function. Okay. So we've seen functions already, right? We've used them all the time. We may not know it. Print is a function. Input is a function. Int is a function. Okay. Those are functions that are pre-done. Someone's already coded them for us. They're somewhere out there in Python that we could theoretically look it up. Okay. But we're going to be able to add our own custom functions to that list of functions. Okay. And again, we can send them things and they can return things. Value returning. So the first is void. The term void is used in C++ a lot, C and C++. which is the next class that you guys will take. So it's good to get a little preview of coming attractions. Okay. So void just means it returns nothing. Void is another word for nothing. Okay. And we're going to start with those void functions. Then on Wednesday, we'll add in the value returning functions. Okay. So when you're creating your function, from the perspective of the main program, a function can be considered like a black box. Okay. You throw something at the function if there's a parameter or parameters. It does what it does. You don't care how it does what it does. It gives you some result back. Okay. That's all we're doing here. The function names are the same as variables, which means they can either start with an underscore or a letter, and then their names can contain underscores, letters, and numbers. Okay, the number can't be first. Again, like with variables, be careful about naming things underscore as the first character. That tends to have special meaning in Python. Okay, so probably don't do that. Okay. And of course, you can't use any reserved word. You can't name a function if, for example. Okay. So let's look at the basic structure of what the functions look like. A new keyword here is def for define. We define a function. It's going to have its function name. It could have parameters there. Again, a parameter is something you send into the function. Okay. And then whatever statements you have.
Is it function or function?
I'm just making that. It should be function. That's just the name of the function. And then whatever statements you have to be indented. Okay. Be as many of those as you want. You're only out of the function when you're back out to the left. Okay. Then I would have to do something like this to actually call the function. So it's important that just writing the function doesn't do anything.
So we've already been doing this.
We've been using functions, yes. We've been writing functions.
We've like the statements and stuff. It's like the if statements.
Right. So we define a function called message, for example. I'm on page 213. Print out some naughty Python stuff, since that's why the language is called Python. Print Arthur. Print. Great. Okay. So note that when we do just this, nothing happens. It's fine. There's no error. It just didn't do anything. We haven't used it. We've defined it. That's all we've done. That's what the def does. Okay. So what happens when your interpreter, when it's running the program, I hit run, it hits this define message line. And it says to itself, okay, I've got this list of functions I know about. I know about print, I know about int, I know about float, all those, input. I'm going to add to that. I now know about message. Okay, so I can do a message now. And it ignores everything else until you try to run it. Okay. So that's why it doesn't run anything, because you haven't told it to run. So at some point, somewhere, you have to actually call the function. Like other functions with the parentheses. Okay. You run that, now it runs. Okay. Run it multiple times, and it's going to keep doing it every time. Okay. So note that until you run it, it's not going to check for any syntax errors. That's a syntax error. When I run it, it's like, cool, no problem. Okay. So it doesn't actually do anything inside of here at all until you run it. Now, if I add this down here, now it's going to find that error. So until you run it, you haven't tested it. You run until you do this. Other questions on the concept of this?
That just makes it work simpler, right?
It does.
If we use something that we know we're gonna use again, we can store it and then just call back for it.
Yep. And you can call it wherever you want. If you've got it 100 times in your program, you just have to do it one time. Okay. So the other thing we're going to be doing, but there's a problem here. There's a dark side here, or a downside. And that's if we happen to call a function before we've defined it. We do this, it's going to be, I have no idea what you're talking about. Okay?
Because it hasn't defined it.
That's right. This is not, if we were in C++, C++ goes through the whole program, compiles it all, works it all out. C++ doesn't have this problem. Python starts at line 1 and says message. It's like, I don't know what message is. I don't know what message is until line 2. Okay?
But that's probably better for us, right?
Yeah. 100%. But what we're going to do to avoid this problem, we don't want that to be an issue, right? So this is another paradigm changing moment for us in programming. Remember before we just do what we wanted, then we had to start checking all the input for validation input loops. Now we have to add a main function to every program that we run. So let's take a look at what this would look like. So I'm just going to temporarily get rid of that. Okay. So let's say we have a normal program that's going to take the input two numbers now. Okay. So we've got x is equal to, this is what we've got up until now. Int input, make it simple, number, y is equal to int input, number. See, I'm going all in on the user interface. Then we're going to print is x plus y. That's all we're going to do. Okay. That would have been acceptable before if that was a challenge. So we enter in 5 and 6, we get 11. Okay. So what we're going to do now, every program from now on has to have a main function. So the main function takes the place of what you would have done before as your program. Okay. So to convert this one, you would just take this, highlight it, hit the tab, move it all over. That should move everything over. Okay. And define this as main. And then the very last line of my program is going to call main. Okay. So what this does is that it's going to go through your entire program and not execute anything till the very end. So you've loaded all your functions. You don't have to worry about any of that stuff. Okay. But I will say that practice dictates that your main function is at the top. And that makes sense as well, because the way we were doing things before, of what we were just doing with the functions, you would have to define all your functions before you used them, right? So your actual code that you executed would be at the very, very bottom. And that's kind of weird. You probably want to know sooner than that, okay? So it makes sense that we're going to have the main function, the main module, right at the very top. Okay, so that'll be our first thing. So now, of course, we can use this to instead call our program. Okay, so I can up here print message for you. Get from the book. Then we're going to call that message function. Print. Okay. So look at the code we have now. So we're going to start off. The cursor is going to be the interpreter. It comes here, that's a comment, we don't care. Okay, we go to here, and it's going to say, okay, now I know where main's at. Okay, we've got a main function, don't care what's in it. And that's indented, so I ignore it. Go to this line, oh, now we've got a message function. Don't care what's in it. It's only here. So if I ask the question on a test, what's the first line to execute in this program? The very last line is the first line to execute. Okay. When this executes, it goes here. It then moves to here and says, okay, print this message. We can do that. It goes here. When it sees this, it's going to now drop down to this message function. It's going to do that, print out that. So we can bring out that. When there's nothing else here, there's no lines that are indented, it's going to go back to the next line after the call. So it goes back to this print, prints goodbye. Now this is done, so it goes back to the next line after the call, which is nothing, so we're done. Okay.
Have a function inside of another function.
You can, but that's not what we're doing. These are two separate functions. These are independent. You can call a function from another function.
Yes.
Yeah, and we do that a lot. But no, we still have two separate functions. Okay. So we're always going to have the main function now. We're always going to call it, but we can have other functions as well. Okay. Questions about this? Note that inside of my function, I can do everything I can do in a normal program. I can do a for loop. Do an if statement. All this random crap I'm doing. All okay. So for main, if I then call F1, it's going to print a bunch of units. 50 units. Okay. Say F1. Bunch of units. Okay. So what inside of the function, you can do anything that a program can do. There's no limitation. Questions so far? Whiteboard up here. So when you're planning out your program, you have to look for reasonable places to start changing that and start breaking it up in pieces. There we go. Okay, so we now got a flow chart of what we just did. And so we're going to make some changes to our flow charting here because of the functions. So the one we just did, we had our main function. And instead of a start, we're going to put the function name in the start bubble. Start over. And then if you remember from that, it displays, I have a message for you, blah, blah, blah. It's a print statement. It then makes a call to the message function. We're going to make it look like it's going to look like this. Wait until my paint out the window. It looks like a process box, but we're adding these two lines. That's now a function call box. Okay. You're going to put the name of the function. Only if your pen writes. That's going to be a call to the message function. Okay. When it comes back, we have one more display the goodbye. Okay. Then we're going to say return instead of stop. Because it's going to go back where it came from. It always stops when it's done doing things. Okay. So this is what that program is going to look like that we just did. But we now have to make this message. Okay. So the message is going to be its own flowchart. It's going to go down and it displays Arthur, blah, blah, blah. It's going to display King of the Britons, blah, blah, blah. Okay. That's all it does. Then it does its return. And we can look from this at the flow here. So if we've called, if the main's the first thing that happens. So the first line that executes in our program is this def method. No, it's not def, it's this method. Okay, it's going to go to right here. Okay. We're then going to go and print out, I have a message for you. We're then going to go to the message call. Okay, there's no parameters, so the control is going to pass now to, it's going to jump over to the message function. Okay, it's going to print I'm Arthur, it's going to print King the Britons, it's going to hit this return. Okay, the return is going to take it back to the next line after the call. Okay, so it's going to take it back to that area. Okay, after the message call. It's then going to go on down to here to print out the goodbye, and then prints out that return, and now we're really done because there's nothing else to come. Okay, so that's how that's going to work. Okay, so questions about that? And again, the basic idea behind our function, these are not mathematical functions, although they're similar.
So wherever you put that function, it's going to stop doing what it's doing, not do that function.
Yep. And if we had a function call a function, well, that's what we're doing. We could have a function call a function call a function. If the message function called another function, it would just stop where it was at and go to the next one. Okay? But a function we often think of as like a big black box. Okay, we can pass stuff in that. These are the parameters. So I can send something into the function. Okay, it can do something, and then I can also send something back out. So void functions don't have that arrow to the right, and some functions don't have the parameters coming in. Okay, the function we destroyed, the message function, didn't do anything. Another planning tool that you can use, and this is on page 219, it's the idea of the hierarchy charts. Okay, so again, this is for the employee pay function. These charts are not flow charts, they're all rectangles, but they're not processes, they're just names. This is more like an organizational chart. Okay, and there are no arrows, they're just lines. Okay, so for example, we could have, oh, at least the pen works. Get input is one of the tasks, one of the functions we would do. Okay. And that could be subdivided into the get hours and the get rate. Okay, and there could be other functions. Okay. Note that this does not mean we're not going to have in our function a def get input, and then underneath that, a def get hours. That's not what we're talking about. Okay, it just means that we're going to call them in this fashion. Okay, but they'll be their own standalone functions. Okay. So the next thing we're going to do here is this example. In the spotlight on page 219 it starts. Okay. This one makes the assumption that you're writing a program for a appliance repair store, and they want to basically have instructions on how to do basic tasks. So they've asked us as a demonstration to write it to how to disassemble a dryer. Okay, so there's going to be an introductory message followed by 4 steps. Okay, so to diagram this out, we have our main function. It's then going to call startup message function. It's also going to call step 1 function and step 2 and step 3 and step. Okay, that's the hierarchy. So the startup message will be like, how to disassemble a dryer, and then step one, you do this, step two, you do that. And the other thing, which we've done before, but I think it's new in the book, if you want to have the user hit the enter key to continue, you just do an input, you don't set equal to anything else. That's all, that's all. So let's take a look how we code this. Okay, so we can start small here. We're going to have this main. Okay, so everything we do is going to look like this, right? There's no change there. All of our programs will look this way. So and here's how I would build this. The first thing we're going to do, we want to display the startup message. We call that function. Okay, it doesn't exist, so I have to create it. F startup message. When that's called, it's going to print how to disassemble a dryer or dryer. Put a new line character. That's all that's going to do. So after I do that, this is where I want to use the input. And say, press enter to continue. We don't care what they enter whatever they want. But as soon as they press enter, we're going to ignore what they've done and just go to the next line. Okay. So we can check this to see if it works. Of course, the enter's not going to do much. Yes. Can't see it. You press enter and it goes on. So we're good. We then want to, I'm going to put a blank line there, which is perfectly okay. I want to print out the step one. Okay. And I want to say press enter to say C step one. Okay. So they're going to call the step one function. To do that, we have to create the step one function. Okay. Say step one. Print. I'm doing an abbreviated version. Unplug the dryer. Basic. So this will print that message out on the screen. We'll then do another input. Press enter, see step two. See if this is working. Run this. Okay, there's the first thing. Press enter to see step one. We do. Unplug the dryer. Press enter to see step two. Okay, looks good. Not step two yet, but oh, it is. Okay. I do want to put a new line character there as well. Okay. And now while I'm at it, I can just go ahead and copy this part at least. 2, 3, 4. 2. Oh. That's 2. Step 3. Step 4. Okay, so step 2 is going to be remove the screws. Step 3 is going to be back panel. Step 4 is take off the top. Okay. So again, I still haven't called any of those things. So it's still going to do what it did before, right? It's just going to give us. So I have to go back now and add this code as well. Step 2. 3. We'll do one of those because we're done at that point. Back to there, go to step 4. Step 3, and say press enter to see step 4. Here, step 3. Open it. Okay. So here's our main, calling at the bottom. Here are all the functions that we're calling. Run this now. There's press enter to see step 1. There's step 1. And I probably should say step 1, step 2, but see step 2, remove the screws, see step 3, the back panel, see step 4, take off the top. Okay. That's how that example works. Any questions about that?
Leave it at 50%.
What's that?
Leave it at 50%.
I can. Again, if you call something the wrong thing, it's not going to work for you. It's going to give you an error.
We don't need something for
No, because there's nothing else after that. You're done with that. You can print done, and that's probably not a bad idea. To let them know that they won't be looking for that fit step. And these void functions are often, since they're not producing a value, often they're going to do a print. Right? But here, this is not the book, but this is one of my golden rules of programming. If a function prints, it should only print. So going back to the idea of code reuse, if you have a function, for example, that determines if a number is prime or not, okay, you don't want to print out in that function whether it's a prime number or not, because that's going to tie you to a certain format. To make it more generic, you're going to want it to return true or false. Okay, so you shouldn't do any printing inside of a function unless printing is all the function does. Okay. So you do probably want it at this point. Okay. That makes more sense. Questions on this?
So this is actually going to save us some more time too, right?
Yeah, should be simpler, easier. Yeah. Yeah. And we're not doing the really cool stuff today. So for that reason, for the homework, I had to kind of wing it a little bit, make up some stuff. So let me show you the homework. So the first one, I want you to go to homework, exercise 12 from chapter 4. It's one of the ones we did. That's a Fibonacci. That was probably in maybe homework 3 of chapter 4. Not a Fibonacci, factorial.
Oh,
yeah, it's factorial. Yeah. So in order to convert that to be using a main function, all you basically have to do is take your existing program, highlight it all, hit the tab key, move everything over. Add a def main, call your main, you're done, right? So that one should be pretty basic, assuming that you've done the factorial. The other one's a little more convoluted, doesn't make any sense, but should be okay. So in addition, now no, I'm not going to say write a main function. That's assumed. Okay. So I will no longer say make sure there's a main function. No, that there's going to be a main function for it's over. Okay. But in this program 2, I want you to write another function called menu. And what the menu is going to do is going to print this on the screen. That's all the menu function does. It prints 1, say dog, 2, say cat, 3, say monkey, and 4, exit. That's it. Okay. Your main should then call the menu. And it should then ask the user for which choice you want. Okay. And if they choose a 1, you should print out dog on the screen. If they choose a 2, you print out cat. A 3, you print out monkey. In either of those 3 cases, you then call menu again, display the menu again. They enter 4, you exit the program. That should do that. Questions about the homework? Someone submitted already. They're quick. Good. You're on the ball. I have my first class at 9 o'clock. So. Yeah. Other questions?
So we wrote the menu function.
Yep.
And the menu function like prints. We call menu.
Yep.
To say dog.
Yep.
It's gonna print dog, print cat, print monkey.
Yep. But we're not going to ask them their choice. You're going to do that back in May. The menu does only printing.
Yeah, so we don't say, yeah, we don't ask them to print, we print it.
You print and then you ask them what your choice is. But you ask them what choice they want
Back at the top.
in May. Okay? Makes sense? Okay. If there are no questions, we'll call it a day. We're about 7 minutes early. That's okay. This is the shortest of the stuff. We will have lab tomorrow online, as always. So make sure that you log in for that. You can come in here if you want, go wherever you want.